All right, sports fans, this is an instructional video on how to draw Bohr's model of the atom. Remember, this is not what atoms actually look like. You've been lied to. But we draw them this way so that we can see all the different subatomic particles and where they are. And we use these boxes from the periodic table, like this one up here for oxygen, to show how to draw it. So this is what will be on your upcoming test when it comes to how to draw Bohr's model of the atom. So we're going to do oxygen today. Oxygen has this number at the top, our atomic number, and then this number down at the bottom. On your periodic table, remember this has already been rounded to 16 because we like you. And that's our mass number. So to start off drawing, we normally start with the nucleus, right in the middle, okay? We'll use a circle, or you'll already have one to represent the nucleus. The only thing that goes in there are protons and neutrons. That's it, nothing else. We start off with protons. This 8 up here, the number at the top of your periodic table, or the atomic number, represents the number of protons. No tricks, no curveballs, 8 protons. You can use the shortcut and go ahead and put a P for protons and just tell us that you know there are 8 there in the nucleus. This number for a neutral atom also tells you how many electrons it has, but that comes later because the electrons are around the outside. Okay? So to figure out neutrons, what we have to do is come to the number at the bottom, our mass number. This number equals protons plus neutrons together. We already know that of those 16, 8 of them are protons. So simple subtraction will get us the rest of the way. If we take 16, that's protons and neutrons together. Oh, it's right in this giant, sorry, we'll do that right here. If we do 16 protons and neutrons together, minus the 8 that we know are protons, what gets left over are the number of neutrons that go in the middle of that atom. Okay? So an N for neutrons, and that equals 16. All right? Oh, gosh, 8. That is what we do for the nucleus, protons and neutrons only. Atomic number tells us protons. Subtract that from the mass number to get the number of neutrons. All right? Now, electrons are where things get a little bit crazy. Electrons go along the around the outside of the atom, but according to Bohr, there were these different energy levels that they belonged in. We use a separate circle for the first energy level. Don't be sticking your electrons on the nucleus here. We need our first energy level. Now, our first energy level can only hold 2 electrons. Remember, for a neutral atom, which is everything on the periodic table right now, we have 8 protons, which means we have to find a space for 8 electrons. The first energy level can only hold 2. So we can put an electron here, and we're going to ask you to start putting an electron, the second one, right next to it. They pair up with one another, okay? That energy level is now full. I know it looks like there's more room, but there's not. You'll see why later. This second energy level can hold up to 8 electrons, all right? Your periodic table is actually designed in a way to show you all of these trends and patterns. We'll point that out to you on another day. This energy level can hold 8 electrons, but we've already found a home for 2. So now we just need to find a home for the remaining 6. Please watch carefully. You will be graded on how your electrons go into this energy level. We already have 1 and 2, so electron number 3 can go anywhere, but remember it will not be paired up yet with another electron until we put our 4th one, our 5th one, and our 6th one. These first 4, half of what can fit in there, go in unpaired, okay? Really doesn't matter what order they go in as long as the first 4 on this second energy level don't pair up with each other yet. So we have 1, 2, 3, 4, 5, 6 electrons. We need a home for 2 more. These next 2 will pair up. You can choose which ones you want to pair them up with, but they will now go next to one of the existing electrons to form pairs. Okay, and that's how we draw Bohr's model of Bohr's model of the atom for oxygen. Okay, the other elements on the periodic table, although the atomic number and mass number will be different, they'll follow the same procedure. Remember, electrons are the real money makers. That's where the real skill comes in. Okay, protons determine which atom this actually is, which element on the periodic table. Neutrons control really most of the mass along with protons. And the electrons, although they don't have much mass, do have a big part in what the charge is on this atom. Okay? Questions? Come and see me sometime.